I'm not going to go too deep into the company overview. We do have an information sheet. We can get out to you afterwards as far as exactly how big we are and all that kind of stuff, who our customers are. But I'm just going to keep this really simple. We're an analytics software company. I'll go into great detail about what we actually do. But we think it's key, the analytics part is key to what we do, and I'll make sure you all fully understand that. We're based in Toronto, Canada, Somebody picked up on that, the accent. So you can make fun of me about my accent as you go through the material. And what we do is we provide what we call software-defined infrastructure control. And again, I'll describe this in a lot of detail. A lot of people use that phrase, software-defined, of course, is a big buzzword. I think this is a legitimate use of that phrase when I get through what we do. Hopefully you'll agree. And control is a big part of what we do, and it's really a path to high efficiency, low risk, high automation in the data center. So let's talk about the problem that we solve, and I'll start with the basics. I think everybody here will be fairly familiar with the concepts I'm going to be bringing up. Hosting infrastructure in general is complex. Data centers are complex. The applications are complicated. They're getting more and more complicated. We have software-defined things happening. And if you look at a workload, over the run of a day, there might be workloads that are CPU intensive. There might be others that are memory intensive. So we see variation, of course, in the resource requirements of workloads. We see some that are busy in the morning, others that are busy at night. We see these patterns. If you look at the data, it will show you this stuff. And if we look over long periods of time, you can get an envelope of what workloads tend to do. So the question becomes, how do we combine these together in the optimal way? How do we map that demand to the infrastructure supply in a way that makes the best use of it and also leverages a lot of flexibility we're seeing in our new software-defined environments? And to really kind of drive home that point, we like to use the analogy to the game of Tetris, which is actually a pretty good analogy. If you look at these blocks I've overlaid, there are these, it's actually not a bad concept. There's ones that are busy in the morning. I need to put them with other things that may be busy at night to make the best use of the resources. So how I combine the workloads is like a big multi-dimensional game of Tetris. And I'll revisit that as we go through because it's actually not a bad analogy. It kind of captures it across many dimensions. So if we look at the server capacity as a playing field and the demands as these different shapes and sizes with different requirements, I showed some of these: compute, storage, I/O rates. Even software requirements. It's not just workload requirements, but also they might have certain needs as far as what software is licensed or compliance or proximity to certain services. The real challenge we see is that a lot of environments we go into, and I'll towards the end of the section I'll talk about some of the customers that we have. It's like a badly played game of Tetris. And again, that's a very, very good analogy. It's basically, as you place workloads coming in, if you rely on something that's looking at the last 5 minutes of data or doing a very simple or random algorithm, it's going to jumble things together, and you end up with, at the same time, stranded capacity and operational risks. You'll have a lot of nooks and crannies of capacity that can't be used, or you're out of memory but you still have a lot of storage left, or at a certain time of day there's plenty of resources but nothing can use them because at 9:30 in the morning you're strapped. So we see that there's the opportunity to get more put more work into this environment, but at the same time, we're kind of in a lose-lose that we have risk. We might have contention for resources at certain times of day. So even though the resources aren't used most of the day, sometimes they're overutilized. And of course, everybody loves it when this happens. The better way is to kind of look at these things in detail, look at the patterns, look at how they all interact all together, rather than looking at them one at a time as they're falling and trying to keep up. Let's look at the whole picture and say, if we combine them in this way, we're going to defrag the capacity. We're going to free up stranded capacity that we can put to productive use. And at the same time, we're going to give the resources to the workloads when they need them by making sure that they're not running into each other at times when we don't want them to. So very kind of simple analogy, but we'll carry that forward because we find it's quite useful to illustrate what we do and kind of use that to compare what other products might do. So really the other way to put this is, if I can move forward here, is placement. Sorry, my machine here is not... Placement. It's all about placement. We figure out where to put stuff. We also figure out how big to make it, but the main thing is where do you put it. And we do that at multiple levels. And this is where it starts to get interesting. So at one level, if you're talking about physical servers or blades and how the workloads fall on it, that's one level that we do it at. And we call that supply side optimization. So I've got infrastructure and I've got all these workloads from different lines of business or applications. How do I put them together to make the best use of that infrastructure and drive up the density? So really, we like to use the word densification. We're trying to drive up the density safely and drive down the unit cost of using that infrastructure. And At the same time, and that's interesting, but at the same time, what we've also seen, and this is more recent, is the need to do this at a macro level. So now that I have the ability to do this within an environment and say I can optimize it, let's look globally now. I have many different hosting environments in different geos with different technologies, some OpenStack, some VMware. They each have a very complicated resource situation, different amounts of free capacity or disk or memory or whatever that is, different capabilities. I'll talk more about this afterwards. So if we have a new workload that we want to host, figuring out where to put it is actually a bit of a challenge. We see a lot of people doing this manually or with spreadsheets. And a lot of our larger customers.
How is this different than DRS and storage DRS?
Well, I'll cover that in a second. That's the very next slide, the approach that we take. So at this level, what we're doing is, this level would be kind of analogous to a DRS at that level. This is kind of much beyond that. This is more at the enterprise level saying, I need to put that in San Francisco, that VMware cluster, that environment, because it has the right amount of disk, that's the right tier of disk and that type of thing. So routing and reservation is what we call that. And we might be doing that for immediate requests or for something in the future. A month from now, I have a new app coming out. I need to find space for it and lock it. And so that's what that piece does. And to relate it to a DRS, so that's basically, on top of that is policy. And we're very big on policy because that's how we codify how we want this environment to operate. And again, I'll talk more detail in all of these areas in the coming slides. To answer the question of how we're different than DRS, because that's exactly what people tend to ask next, our whole approach, so if you look, what I'm going to do now is go out of IT for a second and into robotic control theory, because we've been doing some work with one of our big partners, a big consulting firm, on some of this stuff. And if you look at robotic control, this is a slide from a university in Germany, but NASA has the same slides, MIT, it's the same concept. There's different kinds of control. There's what they call deliberative or symbolic control, or reactive or reflexive control. And as you might guess, reactive is kind of like you bang your knee and you kick. It doesn't require a lot of detail, it just needs to be fast. So there's a kind of a reflexive response. At the other end of the spectrum, being more deliberative, it's not a great marketing word, but it is the word they use. It means being more predictive and having a more complete model of what's happening. And that's a very important thing. So the policies, all the data, how much do I know about the situation so I can actually automate what's happening? And the analogy I would give is that the right side is like kicking when you bang your knee. The left side is like I'm going for a drive and my GPS needs to tell me the best way to get to work. And it needs to know the one-way streets and the traffic and all kinds of detail. And that just is the name of the game. So it needs a bigger model. It's slower to respond, but it's more intelligent. The right-hand side is faster to respond, doesn't need all that detail because that's not its purpose. So DRS really is squarely this right-hand side. And we are that left-hand side, and the two work seamlessly together. So I'll show you in some coming slides. We actually pull up the rules and push down the rules, and we wrap around DRS to make it more of the safety net. And when we do our job, it becomes less active. So volatility goes down because you shouldn't need to move it. We've looked at it, and it should be okay at 5 p.m. You're not just kind of constantly reacting and kind of making another situation.
So do you see this being used in a case where I might have multiple availability zones?
Absolutely.
And be able to control, because to be honest, I mean, a developer that's developing something doesn't necessarily know that every one of his workloads, he doesn't know how to split that between availability zones. Right. But you can orchestrate that through this.
Yeah. So when I get into it, what they should be able to do is describe their requirement.
Okay. So
and then there's the capabilities of the infrastructure, which I'll get into.
I got you.
And the policy that links them. So if you're saying you need redundancy, well, we'll figure out what that means, and we're going to put you away from that.
Right.
You don't need to worry about that. That's one of the big problems we see is that the developers have to speak the language of infrastructure to get anything useful done. Exactly. And you can't get away from it. They still need to know megahertz and all that kind of stuff, but at least we can kind of model that. We call that a portable demand model. Okay. So that's
you'll get into that?
I'll get into that, yeah. And I'll get into policy because some people call policies different things. Yeah. You know, what you need isn't a policy. What you need is just a blueprint or a template. That's right. So I'll come back to this. I just want to stress this predictive and completeness of world models, because that, especially that second phrase, does capture. Again, this is just a kind of it's not a very pretty slide, but it does capture some very key elements. That is a requirement. Again, there's probably analogies all day long. Google self-driving car, it probably needs to have a fairly complete world model so it doesn't run somebody over. That's the
right.
So let's go a little bit deeper.
But to be clear, it works next to the DRS, right? It's not
alongside. We don't conflict. We work with it. Absolutely. Yeah. And there's a slide that kind of illustrates that in some detail. Right. It's very important for us. If you look at the whole VMware ecosystem, we're very complementary with all of it, because none of it really has analytics for placement. There's DRS, which is more 5-minute data, and there's performance analytics, the Integrian stuff, but there's nothing that does this. So that's why pretty much all our customers have all of the VMware products, and they plug us in. So how does it work under the covers? I should have mentioned there's really two sections to this presentation. There's a few more slides on the overview, and then I'll do another section in detail where I get into the topics more and talk about software-defined infrastructure, SDN, that type of thing. But we start, now this is I'll spend a minute on this slide because it's a differentiator for us, is how we work. It's back to that, the analytics and the control. We start by taking the infrastructure, the workloads, the supply and demand, and we do a very detailed analysis of it across different constraint models. So picture it as, certain workloads can go in certain places or go with others because of technical reasons, because of business reasons, and because of their workload patterns. So, for example, I might have workloads that aren't compatible with certain infrastructure, or aren't allowed to coexist with another business group, or their data is not allowed to touch each other. And of course, the utilization data is those patterns I was talking about, the utilization curves. And so we do an analysis of what can and can't go with what to a very detailed level, and we do that by pulling it all together into a three-dimensional structure. So we call it the cube for obvious reasons. And basically this models all of the constraints on an environment. CPU, memory, overcommit, active memory, configured memory, overcommitted memory, business constraints, anti-affinities, affinities, DRS rules come into here. It all goes there, and it's all driven by policy. So if I point this at a production critical environment, the policy might say, hold back a lot of capacity for failure. Don't let certain things touch each other. Don't have any risk of contention in workloads. Dev test might be the other end of the spectrum. Just ram them in and use all the memory. I don't care. If something fails, we'll deal with it. So by turning these knobs, you can affect how the environment is controlled. And that's one of the reasons we call it software-defined infrastructure control. Even virtual infrastructure with no SDN will be more software-defined if you have these control points to control it. With the same hardware and the same hypervisor will behave differently based on that. So that's kind of the engine behind the scenes. If we look at the use cases, again, I kind of alluded to these on the earlier slide. One of the big ones is if I point this at a running steady-state environment, it will look at all the VMs, all the servers, all the patterns, all the constraints, and it will basically play that game of Tetris. And when we do that, there are a couple things come out of that. One is we have a console that lets you visualize these environments. And I'll show you what that looks like in a second. If you come by our booth at the VMworld, you'll see these consoles up everywhere. It's a visualization of all the components, the virtual physical systems, and telling you if there's any risks or any actions to be taken to basically align it. But equally, or perhaps more importantly, we also just automatically generate actions that go into the infrastructure. And that's based on policy as well. So if you say, when you come up with a movement instruction, just send it to vCenter automatically. That's what most of our customers do. Usually, upsizing might be automated if you have hot add. Downsizing is rarely automated because that requires change management. But the whole point of this is it runs autonomously. It will basically generate actions and drive automation. And if you want to look at it, you can pop up a console and visualize your environments. And these visualize pretty large environments. We have customers running 5,000 or 6,000 VMs per console. We have some pretty large customers I'll talk about in a second. Some of them running over 120,000 physical and virtual systems in one analysis system. So that's the piece that plays Tetris and makes sure that at the micro level, all the supply and demand is optimized. Above that sits that routing and reservation system. And the way this works is that it basically communicates with all the control analyses to understand the picture in all these environments. How much resources they have, what kind of resources are available, the capabilities of the environment, all those details. And it basically lets you ask it where to put stuff. And it does that through a web services API. So we have a very rich API with models, very well-defined models that you can interact with it to say, I've got a new workload, Cirba. It has these 8 VMs. Where do I put them? So you picture a blueprint coming into this, or a Tosca template, and that's the way it works. So on top of that API we have another console we call the Reservation console, which allows you to use our product to basically do that process. You can define demands, analyze them, see where they go. But most of our customers eventually just use the API. So things like OpenStack, VRA, just talk to the API. IBM ICO, we're doing an HPOO integration. So from a demand perspective, they just talk to the API and it happens automatically. So we can run completely headless, or you can use our consoles to interact with it. It's entirely up to the customer, and usually there's a bit of both, especially in the early days.
And There is like a user portal that, like a non-infrastructure portal that you can redirect users to.
So users would not use the control console because you see everybody's workloads at once. It's more for the infrastructure people. It's kind of supply side view. That one can be mapped to the end users, but we still don't necessarily see a lot of that. Usually it's a more central group managing it.
Okay.
So a lot of our customers would have another end portal.
Okay. And
like Horizon, or a lot of them frankly make their own portals that allow them to make the service
that's where
requests.
That's what I was assuming, that I might want to just tie into your API and create my own front end. And
right. That's what everybody seems to do. Yeah.
Okay.
Yep. So it's kind of shocking, actually. A lot of people, they start with one and they end up making their own, and they all have
there's
different.
not a whole lot to it.
Yeah. No. Exactly.
You're done.
Yeah. So every customer has some kind of code name for their portal that this all comes in through, and we have really detailed process flows that I don't have time to get into today, but because they're kind of detailed for this type of session, but that go through exactly how that whole thing works and what all the layers involved are. So when you make a request saying, Cirba, where do I put this? It does some fancy PowerPoint animations and says, okay, what you're asking for should go in that environment because that has enough of the right kind of capacity, and we're forecasting it's still going to have enough 90 days from now. It's another important part is looking forward into the future to make sure we're not exhausting resources and filling them up. The only last thing I'll mention on this slide is that it's not only for net new workloads, for initial placement of net new workloads, you can also analyze things that are already in the environment. And this becomes a backbone of some very interesting use cases. So we can say, in that environment, those 12 VMs are part of this app. Is there a better place to put it right now? Should I lift it out of there and put it somewhere else? Based on there being available capacity or cost or whatever the case is. So we call that a reroute, and that becomes the basis of things like bursting. So maybe I bring it out and I don't put it back I put it in soft layer, or I put it somewhere else. So that becomes the mechanism to start making these macro level decisions, and I'll talk about SDN towards the end, because that's kind of key to that whole use case, is being able to make broader decisions kind of beyond the cluster. I want to start evaluating now and reevaluating things constantly. I'll take a breath here. Any questions? Any other questions on this?
So do you just use your clusters in your pre-built vSphere environment to decide where it goes, or do you set like SLAs inside of the application?
So we will see the clusters, and you can structure the analysis to be on cluster boundaries, or some customers do VLAN boundaries if they have, it's whatever their mobility domain is. And then within that, you can also model the capabilities. So if that environment is plugged into gold storage and that one's not, that can be modeled. So when we're making the decision, there will be, you're going to land in an environment, that then has mobility, kind of vMotion level mobility within it. But at the first level, we might decide, between which environment, or availability zones, or host aggregates, or depending on, or shared processor pools and IBM power, whatever the technology is. There's that macro and then the micro placement. So we model the request coming in would have kind of SLA oriented requirements for the app, and then the infrastructure has the models of what capabilities it maps out, and then we'll basically scientifically align that. Yeah. And again, there's some more slides that go a little bit deeper into that. All right, I'll just press on. I'll keep my eye on the clock there to make sure I don't talk right off the end of our session. So this is what it looks like. I'll just spend a minute on it. I'm not going to do a live demo, but just because it's kind of an interesting way to view the infrastructure. This is a control console, and it's pointing at a running VMware environment in this case. It is completely cross-platform, so you can see the same structure for Hyper-V or KVM with OpenStack or IBM Power. And we're basically seeing, and I think there's animations here, the clusters, the hosts, and the guests. So what we're saying is those diamonds at the top are kind of hosting environments. The middle squares are the physicals, and the circles are the guests. And when we analyze them, we can render them on a spectrum of whether there is risk, meaning something's running hot, a host has too much running on it, or a guest is under provisioned. The yellow is I have inefficiencies, or I have an opportunity to drive higher density. So maybe the environment's only half full, or maybe the physical server isn't doing much activity. We can put more work on it. And the green zone is kind of that optimal operational zone based on policy. And the center of the green zone is the perfect alignment of supply and demand. So if you were to interpret this, the way you would read this is all these environments have spare capacity. That's if we play Tetris using a detailed policy, this one that's 0.5, we can fit all the work in that environment on half the servers that are in it. So we've got a good bit of spare capacity that I can use up. So we see here that across the board we have spare. That equates to wasting money. We might not have to buy servers for a while. Some of our customers say no new cores for the next 6 months. We're going to use up what we have. But the reason why most environments are that way, that they're not nice over in the green, is because if I go down, I see these operational risks. So I've seen imbalances. Some hosts are busy, others aren't. I see guests that are misallocated. So the environment's kind of strained. And we see around, this number is an efficiency index. We see around 0.5 to 0.7 is where people start to stall. And they stop putting more work into an environment because it's already not behaving very well. And if I keep piling workloads in, it's just going to get worse. So I can tell you almost every environment we go into looks like this. Clouds have a lot of dots in the bottom right because with the self-service portal, people ask for really big VMs. So you'll see a lot of huge VMs, what we call the reclaim zone in the bottom right. This is a virtual environment, but you see this exact pattern. It's kind of a lose-lose of high risk, low efficiency all at the same time. Right?
So this number up there is efficiency index?
Yep.
What is that number? What makes that up?
It's the ratio of how much of your infrastructure you need to how much you have. So 1.0 means you're spot on with the workloads you have and their patterns and all the policy, your redundancy requirements and compliance. You have the exact right amount of workload in this environment or servers for that workload, depending how you look at it. 0.5 would mean you can fit twice as much in that environment as already in it. And if it goes over 1, it means you don't have enough to safely do what you're doing. It might mean, yeah, workload's running, but you can't survive a failure. You don't have a spare server for failure. So we see sometimes them going off into the red if they're running high risk. So, but by far the majority of people are over here. You see a mix, and both of them are issues. One's like a performance risk, and one's more of a financial problem that you should be sweating the assets more.
And I guess the metrics that are making that up are all something that I've configured to say what I need.
Exactly, yeah.
You're not telling me what I need. I've told the tool what I need.
Right.
And then it uses those metrics to calculate that number.
Yeah, so exactly. So we're looking at, and again, there's not enough time to go really deep under here into the metrics, but for all of these components, we're getting all kinds of detailed metrics. In VMware's case, mostly from vCenter, but we can get from other sources as well. So a lot of our customers augment with other sources of data. And the policy says what are all the parameters to keep these within. I don't want active memory going above 50%, and I don't want my overcommit ratio more than 1.2 to 1 for memory. So you codify that, and that's policy, and that's very important because that's the contract between supply and demand. That's what makes it run the way you want it to run. And if you just leave that to chance, the environments end up looking like this. So. Now to fix this, we will generate a series of actions. So if I look at one of these environments, we'll generate, in this case, for the whole environment, 131 actions, move this around, resize that, reallocate resources here and there. And the policy also says where that goes. Is it automated or does it go to a change management system? And if you make those changes, we actually do an analysis of what your environment should look like after you do that. And, in the product it's interactive, but you'll see after making those changes, we have a much better operational profile. We have the dots, the squares being together means you're making balanced use of your physical assets, which is very good. And we've got no VMs in the red, meaning we don't have any critical misallocations. We can't get them all out of the yellow because you can't take the last CPU away from a VM. If it's doing nothing, it's just doing nothing. So if they stay in the far right, usually just turn them off.
You mentioned change management. I mean, does it integrate with any change management just because of APIs? Or do you have specific change management like Snow or something like that? Or
we just make the actions available. Okay. So in our policy, you can say send to vCenter or send it to an external source, and it's available in an XML form. So usually just a bit of glue to send it in.
Right.
We don't call ServiceNow APIs. We haven't found the need to do that, frankly, because our customers just glue it and they do it.
I just think for tracking purposes, like I might, for whatever reason, right?
Yeah.
Be able to have to track that for audit purposes or whatever.
Yeah, so you can layer whatever, we're like the brain that comes up with the answer, and then it usually goes into, again, we're doing the integration now to send it to HPOO, and we already integrate with ICO,
right.
VRO. It tends to go to a downstream process, and again, usually movements are automated. Upsizes are sometimes automated if hot adds enable. Downsizes almost always require change management because you have to reboot the VM, and the lines of business don't like you taking resources away. So that's the control console, and again, so that's back to the DRS, and that's the piece that works in conjunction with DRS. I'll show that in a little more detail. And the idea here is that we're going to do a more strategic analysis to reduce the risk and allow you to drive up the density to get to the center line. And I think there's a little note here. Yeah, so we've actually, I know this looks like marketing numbers, we've done studies across our customers, and pretty broad studies, and we see on average 48% increase in VM density. It's very dramatic, which means about a third of the hardware is going unused. It's kind of the way to consider that. It will also optimize the software licensing at the same time. So if you have software licensed by the host or by the core, The policy can also say, well, nudge those around to minimize the footprint of my SQL servers or my Windows OSs or Oracle or WebLogic. So our customers do all kinds of different packages. And on Windows OS, we've seen about a 55% savings in a mixed Linux Windows environment. So it's pretty dramatic. That actually we find pays for the product very quickly, just by knocking down the bill coming from these vendors. So that's the control console. The reservation console looks a bit different. We try to think like hotels.com when we design this. We want to keep it simple. Down the right are all my properties, all my hosting environments, ranked by how much space they have. The left-hand side are my inbound demands. So I can say, let's go from today forward 30 days or forward to 90 days. These are all my inbound demands queued up in the next 90 days. This is kind of that pipeline of activity that's coming in. So it could be something coming through right now from OpenStack. We just analyze and get the answer back, or it could be next week or next month. This is the stuff that's coming in. And if you open these up, there's all kinds of detail in the model underneath of what they are, what they need, what their anticipated patterns are. Again, it's a very rich model underneath this that we call a portable demand model of what that's going to need. It's like the counterpart to a blueprint. It's like saying it's not how to provision it. It's from a demand perspective what it's going to need, what license it will need, what I/O resources it might need. And we can take that and analyze that interactively or again through the UI, and it will rank and say, well, here's your best place to put it is San Francisco Eng Dev. And you see there's multiple aspects of the analysis. It's fit for purpose, meaning it has everything that thing needs. If you need, I don't know, some hardware cryptography enabled and it doesn't have it, then sorry, you can't come in here. It doesn't have the right kind of storage or whatever that is. It has, on the right, it has enough resources. You'll use about half of what's left in that environment, including storage. Again, very detailed physical analogical storage. And it also can optionally rank by cost. So if you put in the cost model, it'll say, yeah, and that environment's a little bit less expensive than the next one down, maybe because it's a higher density environment. So it's kind of a tiebreaker. So it's going to rank that and say, what are my most suitable environments? And of course, the top scoring one, if I'm feeling lucky, it'll just send it there and route it in there.
We're at VMworld, and it's really easy for me, at least, to get really narrow. But you keep saying environments. What are the different kinds of environments that we can look at for possibilities to move these workloads?
So in this list right here, well, I know this because this is a demo database. That's a VMware environment it's going to. But those tiles, usually they would be a cluster, because a cluster is oftentimes the boundary of a capability. Mm-hmm. Right, so because a cluster may be running a certain policy, so if it's running N+1, that one's not, that might mean they have different capabilities. So those things on the right could be a VMware cluster, an OpenStack availability zone, a Hyper-V environment, their IBM Power live partition mobility groups. So these Power frames, the Unix frames, they have different boundaries as well that you can model. So basically the different platforms that we support, they will show up there, and there's usually a unit the unit of granularity is usually, again, think of it like a capability. If one environment's plugged into SAN storage and one's NAS storage, those would be two different targets because there'd be different logic on which ones land where. VMware cluster is by far the most common default in a VMware environment for those things.
Okay, that answers the question I asked. The question I meant to ask and should have asked was, what are those platforms that you were just listing off a few? So VMware Hyper-V.
Yeah, so VMware Hyper-V, KVM, running OpenStack, IBM Power, and I'm sorry, am I missing any? Red Hat Rev.
No.
What is IBM Power? Is it Power VM or?
Yeah, Power VM. Yeah. We do a lot of work with IBM, and they have a lot of big customers that have Power estates, so we do quite a bit of work with that. Sorry, you asked.
Oracle ODA?
No, so Oracle, no. So we don't support, we get asked about that. We also get asked quite a bit about Exadata for people running that, because they say, well, that model would apply to an Exadata frame and blade, but we don't out of the box do that. The process for extending our analytics is really more data enablement, and then you make a control model on top of that. So it's not hugely difficult. We just try to focus on the ones that our major customers tend to want. And I think that's the next slide, because so the impact of this, much higher precision. A lot of this is done manually. People laugh, and a lot of analysts laugh when you bring this up, because people use spreadsheets a lot. So this is still kind of the stone ages of automation for this kind of capability. But just kind of what kind of company uses our product. So we have some pretty big customers. I'm just mentioning these. I won't name all the customers, but these because this was, we do a yearly advisory conference, and these are the people that showed up last year. And very, very large coverage in these environments, like a lot of them, the entire organization. So tens or over 100,000 systems in some case. So they use all these features for the policy-based management, the routing, reserving. I think all of these are using both those features, and we work with them to kind of define, what we're doing. Is anybody doing Docker yet, or is that next year, or is anybody doing this? And so that drives a lot of things like our hybrid routing plans. Is anybody trying to burst to Amazon yet? That kind of thing. SDN's happening in these organizations. So we work very closely with these organizations.
Looking at Docker?
What's that?
I assume you're looking at Docker.
We are, yeah. And LXD. Again, it's just, Docker's interesting because it's kind of coming sooner because it's coming from the app dev groups as a container, not as a hosting technology.
Right.
Yeah, so.
That could be very interesting.
So, and we're ready for it. There's some work to do, but we already support what we call above kernel virtualization. That's just a different policy model. Are you combining with OSs inside or inside the OS? It's just a different stacking problem. So, for us, not to say it's no work at all, but we're ready for that.